Hello, my name is Will, and this is my report for Physics 2 Lab 3. First, I will do a quick overview of the lab and results. In this lab, we were tasked with both performing an experiment in which we measured the magnetic field at different points around a magnet and creating a visualization of its magnetic field in VPython. In the experiment, we calculated both on-axis and off-axis magnetic field, making sure to account for Earth's innate magnetic field. Using our data and the averages collected in the provided spreadsheet, we were able to find the total magnetic field mu. In this case, I found a mu of 2.28 times 10 to the negative 5 teslas. The next step of the lab was to create a visual of the magnetic field in VPython. For this visual, I inputted my own mu value and then visualized the magnetic field on 2 on-axis locations, 4 off-axis locations, and finally one location 45 degrees off the axis. The resulting magnetic field at those locations is seen here in the slide above. The main physics principle used in this lab is the formula for magnetic field. We use the formula for finding the magnetic, and we also use the formula for finding the magnetic field of a bar magnet. One key component of these formulas that can be seen in both the visualization and the experiment is that the magnetic field drops off the further the distance r you are from the source. This is similar to electric field. The magnetic field drops off at a rate of 1 over r cubed as seen in the top formula. I will now go over how the experiment was performed. Firstly, I was tasked with finding a suitable location for my measurements. This location needed a total magnetic field presence roughly equal to that of 1 in my geographic location. This will help determine if my results are being affected by outside magnetic fields or not. Next, I had to orient the sensor in my device so that it was accounting for Earth's own magnetic field. To do this, we found at what angle the phone was lying that would result in a magnitude of 0 on the x-axis. After setup, I measured measurements on the x-axis and noted the distance from the magnet to the sensor at certain Tesla values. As you can see in the graph, it gets smaller with distance, but it is not linear. Next, I was required to measure off-axis field. For this portion, I moved my phone a distance d per 0.125 meters out and up from the source. This meant it was a total distance of d, which was 0.17677 meters from the source. I recorded the magnetic field on each axis and used the spreadsheet to calculate the total average magnetic field mu, which I was then able to use in my code. Here's my model and results in GlowScript as well as my code. As far as the actual coding went, it was pretty straightforward. I was required to create a function that would calculate the magnetic field B given mu and the distance r, an observation where r was the distance between the observation point and the source. I also created observation points equidistant away from the source on each of the required locations. These were the 2 on-axis points, one positive, one negative, and then 4 perpendicular points, one positive and one negative for each perpendicular axis. The same distance d was also used to calculate the distance on the 45 degree location, which is 45 degrees away from the axis. D itself was a result of the experiment portion and was calculated from the Excel sheet. D was approximately, once again, 0.17677 meters from the source at all observation locations. The visual and the results from GlowScript can be seen here on the right. As you can see, the on-axis arrows move in a direction opposite to the perpendicular arrows. In this case, the perpendicular arrows are blue, while the on-axis arrows are orange. The way this is oriented, the smaller blue arrows are actually the same size as all the other blue arrows. It's just the POV kind of changes their size. The small pink arrow is moving in a direction relative to its angle to the source. It is notably smaller than the other arrows. This is a result of it being off-axis, yet not perpendicular to the dipole moment of the source magnet. And now finally, I'd like to do some analysis. During the experiment, we were asked to note specific observations and whether they occurred or not. The two that I noticed were that when moving from the source magnet, the measured magnetic field was when far from the source magnet, the measured magnetic field was approximately 0. This was done in order to achieve this was done in order for us to orient the device in a way that would help negate the effect of Earth's magnetic field and was essential for collecting accurate measurements. I also noticed that the closer you were to the magnet with the sensor, the stronger the reading, and this is a result of the magnetic field drop-off. Next, a few comprehension questions. If we didn't orient the sensor to account for Earth's magnetic field, it would likely affect the x component as we oriented it in a way that set it to 0. This in turn would also affect our total magnetic field mu, likely making it bigger than it should have been. Also, if we ran the experiment with two magnets connected, it would likely increase the magnetic field at each location because they must be oriented in the same way in order to be connected, strengthening the magnetic field. This may not increase it exactly twofold, however. And then finally, just to touch on potential errors, it was really hard to find a spot where the total magnetic field was accurate for my geographic location, so outside fields may have affected my measurements, causing any discrepancies. Thank you.